All right, so these are some examples from the book. And so what we want to do is we want to find the prime factorizations again. So, we finished off this section learning about how to do the factor tree. And so let's start here with these. Well, let's go ahead and just, draw them here and draw it here, and let's see what we can get. So 243. Well, let's see. What if we add all these together? What do we get? 4 and 2 is 6 plus 3 is 9. That's divisible by 3. So let's go ahead and divide by 3. So 243 should be divisible by 3. That's going to go in 8. That's 24. And then bring down a 3. That's a 1. And so we get 0. So we have 3 and 81. Well, now we can kind of do a factor tree different. Let's not just put prime factors right here because we know 9 times 9 is 81. Well, 9 is 3 times 3. And so that one goes pretty quick once we figure it out. So we have 1, 2, 3, 4, 5 threes. And so this factors into 3 to the 5th. And that's the prime factorization. All right, so that's how that one works. 91. Okay, 91. Well, 9 plus 1, that's 10. That's not divisible by 3. It's odd. It's not divisible by 2. It's not a 0 or a 5. It's not divisible by 5. So we know it's not a 2. It's not a 3. It's not going to be a 4. It's not going to be a 5. It's not going to be a 6 because that. So let's try our first one. Let's try 7 because it's none of those already. So let's go with our first one, 7. So 91 divided by 7. And that's how I would do it. I would just kind of start with the numbers, start with the ones that we don't work, and the first one that, we don't know, we do the division. So 7 goes into 9 once. Subtract that, we get 2. Bring that down, we get 1. 7 times 3 is 21. So hey, we got it. So we have 7 and 13. Well, guess what? 7 is a prime number. 13 is a prime number. So this factorization is just 7 times 13. And that means we're done with that factorization tree. So this is one that was really short factorization, but we had to go through all the different numbers here of our possible, divisibility rules. And we got to the point where we had 7. Well, let's try that one because that's the first one that doesn't work. And then we go from there. Now, if 7 hadn't worked, we know that 2 and 4 didn't work. So then 8 wouldn't work, and we know 9 wouldn't work, and 10 didn't work. So then we would try 11 next. If nothing up to that point worked, we would just keep going up the number line until we found one that worked. And so that one did, though, and so we didn't actually have to do any of this out here. That one was working, and we got 7 and 13. Okay, so that's how I think about this when you're doing these. All right, so let's do some more of these. Find the prime factorizations of 392 and 144. All right, so what I'm going to do is I'm going to look, hey, that's divisible by 2. So we have 2. Now 392, that's going to be a 1. Subtract that, we have 1. Okay, that's going to be a 9. That's going to be 18. Then subtract that, we have 1. Bring down the 2, that's going to be a 6. And that's 12, and that's 0. All right, so we have 196. Well, again, that's divisible by 2. So we have 2 goes into 196. Well, 2 times 9 gives me 18. Subtract, we get 1. Bring down the 6. 2 times 8 is 16. And we have 2 and 98. Well, guess what? That's even again, so we can divide by 2 once more. And so 2 times 4, that's going to give me 8. Subtract that, that's 1. Bring down the 8, that's going to be a 9. That's going to be 18, that's 0. So we have 49. Well, now I have to think about, hey, 49 is 7 times 7. And we knew 7's prime, 2's are prime. So the prime factorization using powers is 2 to the 1, 2, 3, and 7 to the 2. And that would be my prime factorization of 392. Now what about 144? Well, 144, that's one of those special numbers, that's 12 times 12. So we could do 12 and 12 and then work our way down. Or because we know that that's even, we can say, well, let's start with 2. And 2 into 144, well, that's going to be a 7, that's 14. And then bring down a 4, that's 2. And that's a 4, that's 0. So that's going to be 2 and 72. Well, what's that? Well, that's, again, divisible by 2. And 36 times 2 is going to be giving me 72. Well, guess what? Now we can do divisible by 2 again, and 2 times 18, we worked some of those already. 18 was divisible by, or 36 was divisible by 2 and 18, and 3 and 12, and 6 and 6, but we'll do 2 and 18 because we just keep our primes going down. And we'll keep our primes going down again and get 2 and 9. And now 9 is just 3 and 3. And so here we have 2 times 3. We have 2 to the 1, 2, 3, 4, and 3 to the 1, 2. And that would be our prime factorization of 144. Okay. So, if we multiplied it back out, we could, take 2 times 2 times 2 times 2 times 3 times 3, and we should get our 144. And so that's what we're doing now. We're going to say, well, now we have a prime factorization. What does that equal? And so we have to think about, what does this equal? Well, this is going to be 2 times 2 times 2 times 4. Okay. Well, now if we do our association rule, we can say, well, let's associate those and let's associate those. 2 times 2 is 4. 2 times 4 is 8. Now we have 4 times 8. Well, 4 times 8, that's 32. And that would be our solution. Or we could have taken 2 times 2 is 4, times 2 more is 8, times 4 is 32. And no matter how we move these around, we can associate different orders. We can multiply in any order, and we're going to end up with our answer of 32. Now what if we go down? All right, 5 times 2, or 5 squared, I should say. 5 times 5 times, now we have 2 times 2 times 2. All right, so 5 times 5, well, that's 25. So I'm going to associate those. And we've done 2 times 2 times 2 so many times, we should realize that 2 times 2 times 2 is 8. And so now we just have to take 25 times 8. So 25 times 8. And again, I'm going to write it in a vertical format to multiply this because it's going to be a little more difficult. I can't do it in my head. Or I could do it in my head because, if I have 8 quarters, how much is that going to be? Well, that's going to be $2. So this is really going to be 200. So 8 times 5 is 40, 0. 4 here. 16 plus 4 is 20. I get 200. So you can kind of think about that in 2 different ways. You can do the long multiplication, or if you notice that that was a quarter, we have 8 quarters, that would be $2 or 200 since there's no decimal places, and we get our answer that way as well. All right, what do we have here? Well, we have 3 times 3 times 3 times 2 times 2. All right. So what does that give us? Well, if we kind of keep those together and maybe keep those together, we can do something. Well, 3 times 3 is 9. 9 times 3, well, that's 27. 2 times 2 is 4. Now we have to take 27 times 4. Now this one's not quite as nice. It's not like a 25, so we better just multiply it out. So 4 times 7 is 28. 2 times 4 is 8, 9, 10. So we get 108. Now what about the next one here? Well, we get 3 times 3 times 3 times 0 times 0. And at this point, we can say, hey, I remember we have a theorem. It says if I take 0 times anything, I get 0, and I'm done. And otherwise, you have to take 3 times 3 is 9, times 3 is 27, times 0, well, that's 0. 0 times 0 is 0. Or if I see that when I multiply by 0 anywhere, I just get 0 for my answer, and then I'm done. Okay, so that's all I have for this section.